Whenever we are finding some of the inconsistency at the time of insertion of a rows into a table, then we call that as a insertion anomaly. Some content will going to be dependent on another content. If I delete that particular content, then another content is also going to be lost. So that kind of anomaly will be considered as what? Deletion anomaly. Mainly this will going to avoid the data redundancy. So we are not going to have any duplicate data here. It helps to maintain the quality of data in the database. Hello everybody, a warm welcome to one and all. Welcome to the session 1 of chapter 1 in the unit 3 of BCA's third semester subject called Database Management System. In short, it is Dbms. I am Rohini T.S. Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we're going to learn about the chapter 1 of unit 3, that's regarding what? Data normalization. So we'll have the agenda of our today's session here. We will be learning regarding anomalies in relational database design. After that, we will get to know what do you mean by decomposition, why it is required. After that, I will be discussing what are the functional dependencies, what it means, what are its types, and why it needs to be preserved. That is what I will be discussing here. After that, you will be understanding regarding axioms, minima, and maxima cover of this functional dependencies itself. At last, we'll see what do you mean by normalization, what are its type, and along with the example, I will be discussing regarding normalization. We'll get into the today's session. First, we'll understand what do you mean by anomalies. So, anomalies in relational database design. Already you know that we have a relational database. That means we are dealing with tables. If it is a table that has a rows and columns, then what do you mean by this anomalies? So, how this will going to affect the relational database design? So, we'll see now. Anomaly means the inconsistency occurred in the relational table during the operation performed on the relational table. So whenever we are getting some of the inconsistencies at the time of operation which is performed on the relational table, then we call that inconsistency as what? Anomaly. Then that has to be treated properly. If not, the inconsistency will going to be increased. So if there is more inconsistency, then you can't have a proper data. So in order to have a good database design, or in order to maintain the integrity of a data, then inconsistency has to be reduced properly. That is what the reason anomalies should be properly treated. So that there are 3 types of anomalies we have. So if it is not normalized properly, then inconsistency will going to be increased. Then what are the 3 types of anomalies we have here? So we have insertion anomaly, then update anomaly, as well as we have deletion or delete anomaly. We'll see the first one here, that is regarding updation or update anomaly. So already you know what are the operations that we can perform on the database. We can insert the data, we can delete the data, alteration will going to take place, and also we can do the updation. So when it comes to the updation or update anomaly, when we update some rows in the table and if it leads to the inconsistency of the table, then it is considered as what? Updation or update anomaly. Whenever we are updating some data to the table, at the time if some inconsistencies occur, then we call that kind of anomaly as what? Updation anomaly. So let me take one example here. So here we have a worker table. We have worker ID, worker name, and worker department, and as well as their worker address. So you can see if you want to update the address of Ramesh, so in that table we have a worker name called Ramesh. If I wanted to update the address of that Ramesh, then we will have to update all the rows wherever Ramesh is present. So if we miss any one of the rows which belongs to this Ramesh, at that time we can see some inconsistency in the table. So then we can found this updation or update anomaly. See here, wherever we have Ramesh, then we have to change or we have to update their address. So wherever we have Ramesh in the table or in any other table, every table has to be updated properly. If we miss any one of the table which belongs to this Ramesh, or where this Ramesh belongs to any one of the table, if we missed out, then inconsistency will going to be more. So that at the time we can say updation anomaly or update anomaly occurs at the time of updation. So that if during the update we miss any of the single row, then there will be 2 addresses of Ramesh. So you just imagine that is now what now it is Jaipur. Now I wanted to make it as Mysore. So if I miss this row at the time, we can see that for Ramesh it has 2 addresses. So one is Mysore and another one is Jaipur. So that kind of anomaly will be considered as what? Update or updation anomaly. What is the second type then? Insertion anomaly. When we found inconsistency at the time of updation anomaly. Then same way, insertion anomaly will occur if there is a new row inserted in the table, and if it is creating some inconsistency in the table, then we call that as a insertion anomaly. Fine. Then what is the example here? For example, as taken the previous example itself, if we create a new row of a worker and if it is not allocated to any department, then we cannot insert it in the table. See here we have a worker. I wanted to insert a new worker here, but if we don't have any department, if that worker does not belongs to, or if we are not giving any department to that worker, then there will be a inconsistency. How can I get to know that person or that worker belongs to which department and which department name, their work address? We won't be able to understand. At that time, we can find out this insertion anomaly. So whenever we are finding some of the inconsistency at the time of insertion of a rows into a table, then we call that as a insertion anomaly. So that it will going to create an insertion anomaly if we didn't find any of the department to a particular worker. Then what we have next, after this same example, we'll go with the next type, that is deletion anomaly. You got to know updation and insertion. Then what about this deletion anomaly here? If we delete some rows from the table and if any other information or data which is required is also deleted from the database, then we call that as a deletion anomaly in the database. Some content will going to be dependent on another content. If I delete that particular content, then another content is also going to be lost. So that kind of anomaly will be considered as what? Deletion anomaly. So if you take the previous example itself, if you want to delete the department number ECT 669, then the details of Rajesh is also going to be deleted, and this Rajesh details are dependent on the row of this ECT 669, so that there will be a deletion anomaly will going to occur in the table. Let me consider here we have a worker department ECT 669. If I am going to delete this department, those are all depending on this department is also going to be deleted. Then inconsistency will going to be increased. So we have to assign this Ramesh to some other department which is exist. So then we can avoid this deletion anomaly. If not, this Rajesh information is also going to be lost. Then we will find out with, or we are just going to end up with this deletion anomaly. I hope I made it clear regarding deletion, insertion as well as updation anomalies. Let me go to the next concept, that is regarding decomposition. As the name indicates, we are just decomposing the tables to multiple number of tables. Why do we do it? We'll see. The process of decomposition in the DBMS help us to remove the redundancy. The redundancy in the sense what? The duplication which is having more than that same content is present more than one time. So in order to remove all those redundancy or duplication, then we require this decomposition as well as inconsistencies and anomalies from a database when we divide the table into numerous tables. So this decomposition will going to help us in order to remove the redundancy, inconsistency in the data, and also the anomalies. As we all know that we have an insertion, updation, deletion. All those anomalies can be removed with the help of this decomposition. So it's a process of refers to the dividing a relation X into number of tables x1, x2 up to xn. So this is dependency preserving as well as lossless. You will get to know what is lossless in the coming slide. As of now, decomposition is nothing but what? We are dividing the table, or we are dividing this relation into number of sub-relation. Then what about types of decomposition we have? So it can be lossless decomposition, lossy decomposition. You got to know what is decomposition. So if some loss of information is taking place, then we call that as a lossy decomposition. Though we are decomposing or dividing the table into number of table, if you are not losing any of the information, then it becomes lossless. Here you can see lossless decomposition. If the information is not lost from the relation, that is decomposed, then the decomposition will be considered as what? Lossless. It needs to be lossless. Whenever we are decomposing the table, the information should not get lost. Then we call that kind of decomposition as what? Lossless decomposition. And it will going to guarantees that join of the relation. Already all know about this join and types of join. So it will going to guarantees that join of the relation result in the same relation as it was decomposed. Though it is decomposing, we are just going to find the content either in this table or in another table. That is what going to be guaranteed by this lossless decomposition. And then the relation is said to be lossless decomposition if natural join of all the decomposition give the original relation. As I taken the previous one, if you are decomposing it, we should find the content either in this table or another table. Then we can say that as what? Lossless. See the example here. Here we have a table called employee department. In that we have employee ID, employee name, age, city, department ID and department name. So we can decompose this table into two tables. Which are those? So by having this employee ID, employee name, employee age and employee city, I can call these table or I can make the table as employee. And we can have one more table called department, where I can have this department ID and department name. So this department name will going to be dependent on the employee ID. Though we are decomposing it, we are not going to lose any of the information. See, in this which will be going to be divided into two relations called employee and department. In the employee, I can have this employee ID, employee name, employee age and employee city. So if you consider the employee table, up to this column we have. If I wanted to have one more table called department, there I can have department ID and employee ID, and also we can have the department name, so that this employee ID will going to be the common column in both of the table. If you are doing this natural join, we won't lose any of the information. All the column, all the rows will be available as it was in the same table, or though it is differentiated or though it is decomposed. Next is what? We have a lossy decomposition. We got to know regarding lossless. Though decomposition is taking place, we are not losing any of the information. But when it comes to the lossy decomposition, so as the name suggests, relation is decomposed into two or more relation schemas. The loss of information is taking place, or which is unavoidable when the original relation is retrieved. Then we can say that kind of decomposition as lossy decomposition. Take the example here. Here we have an employee info table that comprises of employee ID, name, employee age, location, department ID and department name. I am going to divide this table into number of tables. So here we have a employee details. That employee info is divided into some of the table. In that first table is what? Employee details. There I can have employee ID, employee name, employee age and employee location. And I can have one more table called department details. So in this we have department ID and department name, but here I don't have employee ID. So why? Because whenever we are doing this lossy decomposition, this we won't be able to join the above tables. Employee ID is not a part of this department details. That is why I can't find any of the common column in both of the decomposed table. Then we say this kind of relation or this kind of decomposition as a lossy decomposition. Fine. This is regarding lossy decomposition. Next, we'll see the next concept, that is what? Dependency preserving. So why it is important? Constraints of the database. So why? Because in the dependency preservation, at least one decomposed table must satisfy every dependency. Consider an example. I have a table. I'm just going to divide that table into 3 another sub tables. So at least in any one of the decomposed table should have every dependency. That means all the decomposed tables should be related to one another table in one another way. Then we call as what? Dependency preserving. So though you are segregated, your family members are segregated to different countries or different cities, so all needs to be in the contact. That is what we call that kind of thing as what? Dependency preserving. That has to be there. So why? Because if a relation R is decomposed into relation R1 and R2, I have a table called R that is divided into R1 and R2, then the dependencies of R either must be a part of R1 or R2. So the content whatever we had in R should be present either in R1 or in R2, or must be derivable from the combination of the functional dependencies of R1 and R2. It should present either in R1, either in R2, or it should be present at least when we are combining both R1 and R2. Then we say that as what? Dependency preservation or dependency preserving. So here next we have a functional dependencies. So here you found a word called functional dependencies. What do you mean by this functional dependencies? Is a constraint that determines the relation of one attribute to another attribute in a database management system. What is the relation between one column to another column in any of the table in the database? Then we call that as what? Functional dependency. One of the column of a relation is depending on or having a relation between another attribute or a column of any other table in the database. Then we call that as what? Functional dependencies. Then why it is required? It is helps to maintain the quality of data in the database, and also it will going to play a very important role in order to find the good and bad database design. If we don't have any dependencies, then we won't get to know anything regarding that table. So that dependency should be there. Then we can find out which is a good and bad database design here. So it is denoted by that functional dependency is going to be denoted by the arrow. If you are going to write or if you wanted to specify the functional dependency of x on y, then we are going to write x arrow y. That means this x is depend on this y. Fine. This is regarding functional dependency. So see the example here. We have a employee table, employee number, employee name, salary, and we have city. If you consider this above example, the value of employee number, whatever we have this employee number column. So with the help of this employee number, I can obtain the employee name. Fine. If I got to know the employee name, then I can find out from which city they are all coming. So that is what if I got to know regarding employee number, then I can get to know the employee name as well as their salary as well as the city. So all these columns are depends on this employee number. That is what? Functional dependencies. So if we got that employee number, we can obtain employee name, city and salary. So by this we can say that the city, employee name and the salaries are functionally dependent on the employee number. If I don't have an employee number, then I can't find out what is the name of an employee and their salary as well as the city. So all these columns are functionally dependent on this employee number. This is what functional dependencies. And here you need to understand what is axioms, minima and maxima cover in the functional dependency. We'll see the first one. Axioms is a set of inference rule used to infer all the functional dependencies on a relational database. These axioms are used in order to find out the functional dependencies on a relational database. How one attribute is related to another attribute in the same table or in any other table of a database. In order to find out, we have this axioms. We'll see the next one, that is a minimal cover of a set of functional dependencies. We have axioms, minima and maximum cover here. So in the minima cover, so whenever we have a dependency between one relation to another relation in a database, at least one of the attribute will going to be dependent on the right hand side of the relational table. Then we call that as a minimal cover set of dependencies. So see here, E is a minimal set of dependencies F that is equivalent to E. So both E and F are the relation here, both are dependent on each other. Every dependency in F has single attribute for its right hand side. Whatever the table we have in the left hand side will be what? One of the attribute, at least single attribute will going to be dependent on the right side. Then we cannot replace any dependency X on A in F with a dependency Y on A. So we call Y is a proper subset of X here, and also still we have a set of dependencies that is equivalent to F. So whenever we have this minimal cover or minimal functional dependency, at that time at least one of the attribute will going to be dependent on the right hand side of the another relation. So we can't replace any of the relation here, or any of the functional dependencies can't be replaced in the minima cover. Then what about this maxima cover? The maximum possible number of functional dependencies is the number of possible left hand side into the number of possible right hand side. That means we can have a balance in the maxima cover here, so that the number of possible left hand side dependency into the number of possible right hand side. So we are including a trivial functional dependencies in the maxima cover. This specifies the possible number of functional dependency from left hand side to right hand side. So if we have a 2 dependency from left hand to right hand and 3 dependency from right hand to left hand, so I can say we have a 6 functional dependency. That is what maxima cover in the functional dependency, so that the number of possible left hand side equals to the number of possible right hand side. So if we have a 2 possible functionality from left to right and 3 from right to left, so if we multiply, then both will going to be equal. That is what will going to be specified by this maxima cover functional dependency. I hope you understood regarding axioms, minima and maxima cover. Next, what are the different types we have in the functional dependency? So it includes multi-valued dependency, and also we have trivial functional dependency, non-trivial functional dependency, and also we have transitive dependency. Transitive dependency in the sense what? If you are asking money from your mother should give. Your mother should not ask your father. That means what? Indirectly you are asking the money from your father. That is what transitive dependency. So A depends on B and B depends on C. So this A is somehow depends on C. That is what? Transitive dependency here. Then what are the advantages we have with respect to this functional dependency? Mainly this will going to avoid the data redundancy. So we are not going to have any duplicate data here. It helps to maintain the quality of data in the database. So the dependency preservation should be there. Then we can improve the quality of a data in the database. And also it helps you to define the meanings and constraints of the database. When we got to know the functional dependency, then it will be easy in order to understand its meaning as well as the constraints or set of rules here. And also it will help you to identify the bad design. Anyway, in order to differentiate the good and bad design, we have this functional dependency. That is also one of the advantage here. And it helps you to find the facts regarding the database design, whether it is a good or bad design can be identified with the help of this functional dependency. I hope you all understood regarding this functional dependency. We'll move to the very important concept, that is normalization. So till now we got to know what is functional dependency, what are the anomalies we can have. We heard a word called redundancy or anomalies, inconsistency. In order to remove all those kind of things, so here we have a concept called normalization. Why it is required? Then how do we do it? We'll see. It's a process of organizing the data in the database to avoid the redundancy, insertion anomaly, update anomaly and deletion anomaly. So here in the normalization process, we are organizing the data in some standard. So whenever we are organizing it, at that time we can reduce the inconsistency, we can improve the integrity of a data, and also we can avoid the redundancy or duplication, and anomalies can be removed with the help of this normalization. Then how do we do this normalization? It will going to divide the larger table into smaller table and links them using relationship. So here we are having a large table. Instead of having a large table, we are dividing that into number of table and we are creating a relationship between one another table. In order to link the different table, we are having this relationship. So that the normal form is used to reduce the redundancy from the database table. So mainly we are going to divide the table into number of tables and which will be linking with the help of relationship. So that it's a formal process for determining which field belongs in which tables in a relational database. So with the help of this normalization, we will be able to get to know which column belongs to which table, how it is depends on each other. That is what we will be able to understand with the help of this normalization. Then what are the different forms or different types of normalization we have here? It is divided into some of the types or difference here. First, we have a first normal form or 1NF in short. We have a second normal form or 2NF, third normal form 3NF, and also we have a BOYCE normal form in short, that is BCNF. So we also have certain other normalization forms here. As per your syllabus, you need to understand what is 1NF, 2NF, 3NF as well as BCNF. We'll see the first one here, that is first normal form. If I wanted to say any of the relation which is there in the first normal form, then it has to follow or it should obey certain rules and regulation. What it is, it should have only one single or atomic valued attributes or column. For each column, it should take only one value as a input. So whenever we have a column in a relation, at that time the number of values should be single. It should not be multi-valued attribute. Already you know about the attributes and its types. So it should be single valued attribute or atomic value attribute. All the columns, then values stored in a column should be of the same domain. For example, for age, if at the time of creation of a table, if the age column is determined as an integer data type, then I should give only integer. It should not accept any other value than the numbers. That is what the main rules. All the columns in a table should have a unique name. So I can't take student ID, student name, student name, student ID again. So whenever we have a table, every column should be unique. So that column name should not be repeated. And the order in which the data is stored will not going to be mattered at all. I can include or I can insert the roll number 2 first and roll number 5 next. Like that we can do. The order will not going to be mattered. Main thing is what? That should be single valued or atomic value, and the column should be of the same domain. The value whatever we are inserting should be same domain, and the column name should be unique. Fine. So if the table is to be in first normal form, if and only if all the column contain only atomic value, that is each column can have only one value for each row in the table. No two rows have the same value for all the columns in a table. Then we can say the table is not in 1NF. So in order to make it 1NF, we have to remove some of the content. We'll see the example here. We have an employee table. In that we have employee ID, name, job, department ID and skill. If you consider the employee ID, I have only one value, no problem. Then name is also okay, job programmer, database administrator, department ID 1 and 2. And if you consider the skill, here we have C, Perl, Java. That means what? This is multi-valued. We have more than one value for a single column. That means this table called employee is not in the first normal form. So what I can do, I can take out this Perl and Java and I can include only C. So here also you can see MySQL and PostgreSQL. This is also multi-valued. So this is also not obeying the rules of first normal form. So remove the content, have only one value for each column. Then we can say this table will going to be in first normal form. Next, what we have, second normal form. If you want to go for a second standard, first you should complete first standard, no? Same way, if you wanted the table to be in second normal form, then it should be in the first normal form first. Then, what is the second point? It should not have any partial dependencies here. So here we have an example so you can understand easily. Let me consider the table as employee here. In that we have employee code, project ID, project employee name and project name. As I taken earlier, when it comes to the second normal form, the column or the value whatever we have should only depends on the primary key, not on any other value. So if I wanted to differentiate or if I wanted to make it primary key, I can take the employee code and project ID is also become the primary key of this employee table. So we can find out the employee name by their employee code and we can find out the project name by their project code. That means what? We have a partial dependency in this table, but that should not take place for the second normal form. So what we can do, I can divide or I can decompose this table into number of table. So for example, I can take employee details. So in that we can have this employee ID or employee code and employee name. This become one table and I can have one more table called department. So here I can have next table. So here we have project ID and project name and I can have one more table called employee project. In that I can have employee code and project code. Okay, this is project table, this is employee table, employee department table, and this is project table, this is employee project table. So if you see here, this employee name depends only on the employee code. This project name depends only on the project ID. This project code depends only on the employee code. That means what? All the column will going to be depend only on the primary key of a table, not on any other dependency. Then there will be no partial dependency. If there is no partial dependency, we can say that the table or a relation will be in second normal form. This is the second normal form. Next, what we have a third normal form. So that means what? If I wanted to set it to be the table is in third normal form, then it has to be in second normal form. If it is to be in second normal form, priorly it should be in first normal form. That means what? We have removed the multi-valued attributes and that contains only atomic value. All the columns are unique and also it can accept only one value for each column and no two columns have a same value for all the columns. And if it is in second normal form, then there is no partial dependency. Along with that, we have one more, that it does not have transitive dependency. As I told earlier, if you are asking a money from your mother should give you. Otherwise, the mother should not ask your father. That means it is having a transitive dependency. That means you are somehow indirectly asking the money from your father. That should not take place if you want the table to be in third normal form. We'll see the example here. So here we have a table called employee. In that we have employee code, employee name, employee zip code and employee city here. So if you completely observe this employee code or employee zip code will going to be depends on the employee code. And if we wanted to find out the employee city, that will completely depends on the employee zip code. That means what? Employee code somehow depends on zip code, and zip code is depends on this employee city. That is what we have a transitive dependency in this table. So in order to remove that, we have to make a different, or we have to decompose this table into number of tables. So I can have employee code and employee name as one table called employee details, and I can have employee address by including the employee zip code and employee city. So by having this, we can decompose it, and we are having a number of tables in order to remove the transitive dependency if I want the table to be in third normal form. This is one of the example. At last, what we have last is BOYCE code normal form or BCNF. This is more stronger or powerful normalization form than the 3NF. It will going to remove the transitive dependency whichever we had in the 3NF. So which allowed the right side of the functional dependency to be the prime attribute. So then we can remove this transitive dependency. A table R is in BOYCE code normal form if it for every non-trivial functional dependency X on A, then X should be a super key. With the help of this, we can remove the non-trivial and transitive dependency from any of the table, so that every left side of functional dependency in a table must be a super key. If we have this content, then every table that is in the BCNF is also in 3NF, 2NF as well as in the 1NF by the previous definition. So as you can see that if it is in BCNF, obviously it's supposed to be in 3NF. If it is 3NF, 2NF, 2NF, 1NF, and completely we are removing all the kind of redundancies, anomalies and inconsistencies from the data by having this different types of normal form. I hope you all understood my today's session. Let me meet you in the next session with a chapter 2 of unit 3, that is regarding query processing transaction management. Let me meet you there. Until that, keep learning, keep on growing. Thank you.